In this example, we're going to look at the application problem of writing equations in slope-intercept form. And this involves interpreting the story problem given a situation. So let's go ahead and approach this. It says an Army recruiter, Ms. Cooper, is paid a daily salary plus commission. When she recruits 10 people, she makes $100 total. When she recruits 14 people, she makes $120 total. What is her daily salary? And so if we want to know what her daily salary is, what we're going to do is find out what her rate of change is. We're going to look at what's given to us. We have people and we have total income. We have people and total income. So let those be our x's and our y's. So let's let our x values represent the number of people and our y values represent the total income, the total dollars. And so if I take a look at this, she has for x a 10. For 10 people, she makes $100. So 10, 100 is the first coordinate. For 14 people, she makes $120 total. And so what I'm going to do is I'm going to look at the slope for this problem, her rate of change, and we'll see how this helps us out. So what we'll do is we'll take 120, her y2, and we'll subtract her y1, which is 100. We'll take her x2, which is 14, and we'll subtract her x1, which is 10. And so we get 20 over 4, which is 5. And so that represents the rate of change with the people and her income that goes on. So if we think about this, we see that her daily salary consists of how much she is paid plus her commission. And so we know now that for every person, the rate of change is people over dollars. So for every person, she makes $5. And so what we can do here is we can kind of set up some logic. If she recruits 10 people, she gets $5 per person. We don't know how much she is paid besides her commission, but we know she makes $100 total. And so this is 50. So 50 plus some number equals 100. And so we know that her daily salary is $50. She gets her $5 for every person she recruits. That was our rate of change. And based off of knowing that she recruited 10 people and made $100 with her daily pay and commission, we know that her commission was 10 times 5, which is 50, but yet she made 100, so her base salary has to be 50. We can even see it here. If we were to do 14 times 5, we would get 70. And so her commission was $70, but yet she made 120. And so 120 minus 70 is 50. So that represents her daily salary, $50. So let's look at part B. Write a linear equation to model the problem. And so we've learned, if you think about it, we've got all the information from above. Linear equation means we want to use slope-intercept form, y equals mx plus b, where m is your rate of change. And m was our rate of change. It was how many dollars she gets per person. And so we have the equation for first, y equals 5x. And now we need to figure out what does our slope-intercept form represent. The slope-intercept form actually represents our daily salary, which is plus 50, because that is how much she starts out with every day. And so now, how much would Miss Cooper earn if she recruited 20 people? Well, take your equation, y equals 5x plus 50. Our people is our x, so I do 5 times 20 plus 50. Order of operations tells me 5 times 20 is 100, and then I'm going to add my 50. And so I see 100 plus 50 is $150. So if she recruited 20 people, she would earn $150. So when you are approaching an application problem, what you want to be able to do is identify what your rate of change is. This one was a little trickier because our rate of change represents the amount of money per person. And her whole salary is based off of her daily salary and her commission. And so this actually represents her commission. And so we had to go backwards and figure out how much she is paid daily. And then we apply that to create a linear equation and apply the linear equation to predict how much money she would earn based off of the certain amount of people she recruits.